Let's take a look at quadratic inequalities. So here's a quadratic inequality, pretty straightforward. It's x squared minus x minus 12. So you might think that you're going to have two negative quantities here. And by the way, this would be -1, right? Okay, and so this is here. Here's your constant, and it's a second degree equation, and this is called the quadratic term. And it doesn't matter which letter is used as long as your term is here. Okay? By the way, you could have a third degree equation, be a trinomial quadratic equation, and if you had b squared minus b minus 12, once again, it really doesn't matter what's here, and you would still factor. This would just be, oops, I was about to write x. This would just be b minus 4, and b plus 3. Okay, and let's go ahead and factor these out. When we factor them back, let's do this here. You get x here to make sure that you did it right. That's x squared. You get this term, this x minus this, which is -4x. And then you get this term way over here, which is 3x. But it's a positive 3x. And that's important because that's what's going to happen here to make this -4 here. And then -4 times, I'm going to use a dot for times positive 3 is going to give you a -12. So the factors work, okay? And I'm sorry, I'm scrunching numbers up here for you, but so you do have your original equation, which is x squared. -4x plus 3x is -x squared, or 1x, and then it's -12. So when you take apart these equations, I've done them here for you. You go x minus 4, you take its additive inverse, which would be positive 4, and you take positive 4 over to this side, and that becomes 4. Then you take the additive inverse over here, which would be -3, and that becomes x equals -3, so you're dealing with these two terms. So you have a solution. X either equals 4 or x equals -3. Now this was an inequality. And here's what you're going to do now. You're going to take -3, because that's the smallest number, is less than x, and then x has to be less than 4. You're just establishing a condition here, because you're going to try to figure out how to graph this term. Okay, now step 4 says satisfy any conditions for the two solutions. And what we do is now we put the two solutions on the graph. Now, why are we choosing a part of the axis? And by the way, they're talking about the y-axis and x-axis. That's how you get a graph. And we're going to see that on the next page. But anyway, when you talk about the axis points, they're asking you, how is x less than -3? Why are you choosing to get points this way? Well, simply put, you want to see how far the graph can extend past -3, and or if it can't extend past -3. So you want to take your lowest point, which is -3, and see if there's something greater. Because if -3 is there, probably there's something that might be less than, so or greater. And you want to take your lowest point, and then you want to take your highest point, see if something's greater. And let me say this better. You want to take your lowest point and see if there's something less. And if anything, just remember which way they go. You're going here because now, here's the tricky part. You're going to turn this around, put x in the middle. And so x has to be greater than negative 3, but it can also be less than 4. But let's deal with the first part. This is the lowest term you have. Okay? So see if something is lower, and I chose negative 5. You could have chosen negative 6, because remember on the numbers line that these numbers over here are actually less than because they're negatives. So like if you had negative 4 even, that is still less than negative 3. So then you take negative 5 into the original equation, which was x squared minus x minus 12, and you put that here. Remember, two negatives. This is squared. Negative 5 times negative 5 is positive 25. These two negatives become positive, and then this is minus 12 from PEMDAS. So you have 30 minus 12, which is 18. So yes, negative 5 fits the graph because it is certainly less, and it will work with the equation. Okay? So next thing you want to do when I say work with, meaning that if you plug this value into this equation, it will work and it will come out that it is done this way. Okay, now same thing you want to do here is you want to take this value here. It has to be less than. It could be a 2. It could be a 1. It could be a 0. It could even be a 3. But I just chose 1 because I wanted to get a value. So we take 1, plug it in. 1 squared is 1. These two negatives make this positive. 2 minus 12 is 10. Okay? So 2 minus is negative 10. I'm sorry. Is negative 10 on the graph. Okay, now here's the problem. It's less than negative 3, negative 10 is, but it's not less than negative 4. Than positive 4. So it can't be on the graph. This term has to satisfy both sides of this equation. So the answer is no. It's not on this portion of the graph. So x is greater than 4. So let's take 6. When we take 6, we do 6 squared, we get 36. We get plus 6 minus 12. 36 and 6 is 42, minus 12 is 20. 20 is greater than negative 4. So it's on the graph. So you're okay. Now we want to plot to see what points are on the graph. We do an open circle, and this gets confusing. A lot of people want to shade this circle in and say, oh, let me shade it because guess what? It's the whole circle. Well, I got news for you. Don't shade it like this. Don't do that because this does not have a greater than or equal to sign. So you can't shade it. And these are where people make some of the biggest errors. Okay, so negative 3 and anything that's less than negative 3 goes here. So do you see this line over here that's being drawn? It is drawn out all the way extending over here. So when we put negative 3 here, we have a point here. Now here's the other part of the equation. Is it anything that is greater than 4? So it's not this area. It's not negative 2, it's not negative 1, it's not 0. It has to satisfy the graph. So it has to be greater than 4. So guess what? It's all this area over here. So when your teacher or when an exam or anything you're doing asks you to shade the graph, you're shading all the parts that are outside this line, this parabola, and this parabola goes down. It goes down, remember, to like negative 10, and it goes down this, but that's the area. So like if you were on a test and they give this to teachers when we have to reteach you, which part is shaded, which part isn't, you have to know this. The part that's shaded is the outside part. where these lines are. So make sure you set these up. And you have 2 points because you have a two-sided inequality graph where x is less than -3, but x is also greater than 4. Okay, and so our long graph was this. X, we had -3 is less than x. I did that the wrong way. X is less than -3, but x is also greater than 4. So this is what this graph is. And you have to make sure you do it. If you had this sign here again, you would go ahead and just bubble this in. And we'll get into in another video. Does that change like how the outside part parabola is shaded? Not really. Okay, so this is what's happening. X is greater than 4. So I just wanted to show you what the graph is and what it should look like. It goes down, and even this part is like, you know, kind of like carried to this, but you get the general area that your parabola is going to kind of come down here because your parabola has to touch these points. And a lot of people say, well, why doesn't it stop at 0? Well, if you were given a choice to do 0, the problem is 0 is even with your points at x, so it's not going to be. And it has to include -10 because of the equation we did. And it has to include, so it has to kind of come outside of this area here. If you have any questions, we're at jacobitslearning@gmail.com.